Hello, this is the presentation for the summary of the report of the Math 3301 final assignment. The objective of this report was to analyze a subsection of the Brisbane transportation network using graph theory, to introduce a disruption in the network and observe its impacts, which we will do via a railway accident which disables railway lines, and to include an extension network to see how the network responds, which we'll do via the Brisbane Metro. The forms of transport we are going to consider are the CityCat ferry, the Ipswich, Beenleigh and Cleveland lines, the buses listed on the right, and walking between stops if they are within a 20-minute walk, but only within the circled region of interest on the left, which encompasses the CBD, St. Lucia and several accompanying suburbs around the Brisbane River. The network, when abstracted to a graph, looks like this. We've colored the edges corresponding to the type of transport taken, so blue edges correspond to ferry trips, red edges correspond to train lines, green edges correspond to walking between stops, and grey edges correspond to bus routes. You can also see that the northern suburbs are down on the bottom left with New Farm and Fortitude Valley. The western suburbs are up in the top right with Taringa and Indooroopilly, and the southern suburb stops are up in the top left with Woolloongabba, Dutton Park, etc. I decided to weight the graph edges with time since I was interested in analyzing how people travel through the network in terms of shortest distances. Noticeably, looking at the histogram on the right, the majority of weights of the edges on this network are between 1 and 6 minutes and are relatively short, and there's only a select few weights of the edges that are much longer, and the edges of the graph on the left have been colored to represent the weights, with red edges being faster and blue edges being slower. I wanted to analyze the centrality of vertices, and one way of doing this was looking at the eccentricity. The eccentricity is a good way to measure centrality because eccentricity is the maximum distance between a chosen vertex and any other vertex in the graph. And so the more central your vertex, the smaller the maximum distance would have to be. The vertices in this graph were colored according to their eccentricity. So we can see the red vertices in the middle, King George Square, Roma Street Station and Central Station, they form the center of this graph, and that makes sense because they are located in the CBD, which is physically in the middle of Brisbane, and also since it is the central business district, most of the transport passes through there, and so lots of transportation routes are open. We now consider the disrupted network in which all of the train routes were taken out. I wanted to first see the increase in eccentricity per vertex, because taking out routes will only decrease options for shortest path and so increase the distance between most paths. The increase in certain vertices is quite dramatic, with a maximum increase of 26, which is almost doubling the eccentricity of certain vertices. And we can see the majority of affected vertices are either train stations or adjacent to train stations. And because of the removal of the train network, there's much less structure in this network, and so there's far less of a tightly knit center as seen before, and the eccentricities are far more spread out. Also noticeably, the minimum eccentricity is 34 and the maximum eccentricity is 58, so there is a path in this network now that takes 58 minutes between two vertices, and so this network on the whole is far slower than before. Now if we look at the extended network with the inclusion of the metro edges have been colored orange. The decrease in eccentricity is not incredibly substantial, and the majority of the decreases in eccentricity can be seen to happen up the top where the southern suburbs are, This is likely because the path of the metro between PA Hospital and UQ Lakes provides a much faster route to bridge the two halves of the southern suburbs together. Now, if we consider the eccentricities of the extended network, the most central points appear again to be King George Square, Rome Street Station, and Central Station as expected. However, the eccentricities along the metro line are also much higher as a result, because having access to this faster metro path means they can more easily get to all the vertices. Thank you for listening. That's the end of the report.